real-time feedback into the behavior of your distributed systems, and observing changes, exceptions, errors in real time allows you to not only experiment with confidence, but respond instantly to get things working again.
PurpleTeam is a security regression testing CLI. That's the front end and software as a service back end, targeting web applications and APIs, specifically built for developers. The CLI is specifically targeted at sitting within your build pipelines. That's if you're running it headless, but can also be run manually with a character user interface. You can choose from either local and or cloud environments. If you go with the local environment, you'll need to set up both front-end, that's the CLI, and back-end microservices. If you choose the cloud, all you need to do is get the CLI on your system you want to run and configure it and create a job file. So it's been a 4-year journey that has brought PurpleTeam from a proof of concept to where it is now. I finished writing a book series to help developers upskill their security. And I ran lots of workshops with the proof of concept from that book, Holistic InfoSec for Web Developers, to elicit developer feedback and confirm that what I wrote about was actually true. Now these are the books I've written. You'll notice the Holistic InfoSec for Web Developers series there. Now this is the actual website for it. You can read these books freely online, or you can decide to buy them if you really like them. So the proof of concept that PurpleTeam was born out of was in this first volume. Most of the time it's been 7 days a week, and it's been 2 full-time jobs. I donated PurpleTeam Local to OWASP in Q1 of 2021. Now PurpleTeam Cloud went to market in Q4 of 2021. I couldn't get the publicity that was needed to get enough customers on board to make cloud financially viable, plus family relationships were getting strained. So I donated cloud to OWASP in Q1 2022. So now the community gets to reap the benefits of a production-ready hosted security regression testing software as a service that you can plug into your build pipelines to continuously test your web applications and APIs. Now, building a tool that helps developers write secure code is a great way to learn about security. If you want to learn more about information security, we can assign you a mentor, and you can help yourself and the community by building PurpleTeam with us. Now this is a high-level architectural overview of the PurpleTeam solution in the cloud. And this is the same but run locally in the local environment. So what you've got here is you've got the back-end components, you've got the orchestrator which takes the requests from the CLI and sends feedback back to the CLI too on what's happening with the application, on what's happening with the testers. Now I've got an application tester, we've got a server tester, and we've got a tls-tester. This is your system under test, this is the internet. Now what happens when you send a job file through from the CLI is the orchestrator takes that, it sends it to the testers. Now, with our server scanner and TLS scanner, the emissaries sit within their containers, they're embedded. Server scanner is not yet implemented, but it's going to be soon, and we're going to be using Nikto. The TLS scanner is all up and running, and it's been in production for quite a few months. Now, the application scanner, based on the number of test sessions that are sent through in the job file from the CLI to the orchestrator, we spin up that number of emissary sets Now, these are your stage 2 containers. These are your stage 1 containers. And we spin up n number of ZAP and Seleniums. And the way this is done is that the application tester talks to, in the local environment it's SAM CLI, in the cloud it's just Lambda. And we've got our Lambda functions there which spin up the ZAP and Selenium containers using Docker Compose UI. In the cloud it's just ECS. Now as feedback comes back from the emissaries, the testers are responsible for sending that feedback, or for grooming it and sending it through Redis, and then the orchestrator subscribes to the Redis channels. Now if we're using a long polling between the CLI and the orchestrator pushes those messages back onto a list, so that when the CLI long poll requests come in, the orchestrator can pop those off the list and send them back in batches. If we're using server-sent events, then as soon as the messages come in from Redis, they are sent back in real time to the CLI. For all intents and purposes, it doesn't make a lot of difference which one of these you use. There are small pros and cons on each, and it's configurable in the config for the orchestrator. Once the application testers are finished their testing, they talk to SAM CLI or Lambda if it's in AWS again, which runs another Lambda function to bring these containers down. How does PurpleTeam help us as developers? How does PurpleTeam help us as a business that creates software? And why would I want PurpleTeam in my build pipelines? To answer these questions, I'm going to take you back to a section that's in a number of my previous talks. How have we found bugs in software traditionally? Basically, we haven't really, or we've done it really late. So, our red team has a week or two to find all the defects we've been conscientiously adding for months. So it's approximately $20,000 per week. The engagement's generally 2 weeks for a small to medium web application or API. With a software project before release, it's about 6 months for the same size project, and it's about $40,000 for the 6 months per project. So generally 5 criticals, 10 highs, 10 mediums, and 10 low severity bugs are going to be found. And many bugs are left waiting to be exploited. The business decides to only fix the 5 criticals, and each bug now has an average cost of 15 plus times what it would have cost to fix if it was found and fixed when it was introduced. So that's 5 bugs times 15 times $320, which is approximately 2 developer hours, is $24,000. So the bottom line, for a 6 months project, you're going to have a 2-week red teaming engagement that'll cost you about $40,000, and only 5 red team bugs are going to be fixed at a cost of $24,000. So the bottom line, this is too expensive, it's too late, and too many bugs are left unfixed because it's now so late in the software development lifecycle, and each bug now costs 15 times plus what it would have cost to find and fixed if it was found and fixed when it was introduced. Now these are based on statistics that I documented in Holistic InfoSec for Web Developers, that's my book, taken from various sources. Instead of deferring the finding and fixing of security defects to a traditional red teaming exercise, PurpleTeam helps us find and fix our defects as we're creating them. But how, you might ask? So PurpleTeam runs against our web applications and APIs as we're creating them, informing us of security defects that we're introducing in close to real time. So PurpleTeam reports show us how to reproduce the attacks that were found, and they also provide tips on how not to introduce the same types of vulnerabilities again. So now we know we need PurpleTeam. So for the local setup, we're going to be looking at local and cloud. So for the local setup, we head to the setup page, and we're going to work through these components. So again, we've got the high-level architectural overview there of the local environment. So you need to set up a Docker network. These are the details on how to do that. And you're going to need a system under test. This is the system that you want to be security testing. Now, if you don't have one at the moment and you're just wanting to take PurpleTeam for a spin to see how it goes, then we'd suggest using something like OWASP NodeGoat. Now we use this as well, and we've got a Docker Compose override that you can use to help you get going. And there's also PurpleTeam infrastructure as code system under test, which basically brings up and brings down NodeGoat very quickly with a clean slate each time. So you need to set up your Lambda functions. The details are on the README page here. Stage 2 containers. The details are on the README for the Stage 2 containers there. These are all in GitHub. The orchestrator as well. For the orchestrator, there's a couple of environment variables that you need to set up. You need to apply some permissions to directories. And if you've got a firewall running, you'll need to set up, ideally set up some firewall rules. Yeah, you will need to set up some firewall rules. And you'll need host IP forwarding turned on. Some details there around that. Now for the testers, we've got the application scanner, we've got the TLS scanner, and the server scanner, which is not yet implemented. So the details for setting these up are in their READMEs. Same for the PurpleTeam CLI, which I'm going to show you now. So if you're using the cloud environment, then all you need to do is set up the CLI. You won't need to set up any of those back-end components because they're all done for you. So the CLI install options, there's 3 options here. So if you're planning on running or debugging PurpleTeam standalone with a UI, this is a good option. For this option here, this is good if you're planning on running or debugging PurpleTeam as a spawned NodeJS subprocess, for example, from your NodeJS build pipelines. So yeah, you can run it and debug it as well. And this npm install globally option is good if you're planning on running or debugging PurpleTeam from a build pipeline written in a different language. And you need to configure the CLI. So that's the configuration details there. And this is where you work out, or you define whether you want to run headless or with a QE. And some details around the job file there, which is also found in the documentation. In the documentation on the purpleteam-labs.com website. There's a lot more information there. And these are just the run sections, how you actually go about running the CLI. And that's what these are. So these are the sections in that README just a little bit further down than what I just showed you. So for those 3 options, whichever one of those you picked to install, there's an associated run option that you can use to work out how you're going to run the CLI. It's pretty simple. Now, if you're running in the cloud, then job done. All you have to do is have that CLI on your system and configured, and have a job file ready to feed it. If you're using local, then there's a little bit more to know about running the back-end components. So the back-end components workflow, this is documentation for it, steps you through these sections. So there's some details here around if you actually want to test the lambdas themselves. Generally you won't need to do that, just if you are contributing to the PurpleTeam project and debugging lambdas. You probably won't need to know that unless you're actually contributing. Yeah, so this is the debugging section, the main debugging section. So this is details on how to debug the application, scanner, and subprocesses. So that's the subprocesses that spin up the stage 2 containers, which have Cucumber in it as well. And same for the other testers. The orchestrator is the same, just that there's no sub-process. And for the front end, this is how you run the front end. Also, there's some details around this in the README of the PurpleTeam CLI that we've already looked at. But this is just a little bit more details here. Now, full system run. These are the actual steps for the full system run. So this is starting your CLI and having all the back-end components set up and running, ready to accept requests. I'm going to walk through this soon.
Hi, today I'm going to show you a test run with the back-end components as well. I'm starting Docker stats to show you which containers are coming and going. We start Docker Compose UI, which is responsible for taking orders from our Lambda functions to start and stop the stage 2 containers. We start SAM local, which is responsible for hosting our Lambda functions locally. And we already have our system under test running. Now, once we've built our stage 1 images with npm run dc-build, we can bring them up with npm run dc-up. And then we start the CLI. In the bottom left terminal, you can see the validated, filtered and sanitized job file contents. In the top right terminal, Docker stats is showing us the stage 2 containers being brought up. In the bottom left terminal, we're checking and retrying that the stage 2 containers have come up and are responsive. All testers are now running. As the test run progresses, in the CLI tester complete panel, that's the donut meters, you will see the percentages progress. These are total percentages per tester. In the running statistics panel, just to the right of the donut meters, each row represents a test session as defined in the job file. Here I'm tailing the CLI tls-tester log just to save right arrowing on the CLI terminal to the tls-tester screen and not being able to also see the app tester progress. Back to the running statistics panel. The thresholds you see are also defined in the job file as alert thresholds. A given test session will be considered a fail if the bug count exceeds the alert threshold. Alert thresholds are useful for brownfields projects where you have existing defects but still want a test to pass. These are the definitions. You may find yourself referring to these quite often. Back to the running statistics panel. You'll notice a complete column. These cells represent percentage complete of the test session, where you may have more than one of these for a given tester. In order to initiate a test run, the build user needs to define and supply a job file. This is the documentation that will help explain the schema and help you construct your job file. Next, I'll show you some example job files. This job file is very similar to the one we're using for this test run, except we're targeting nodegoat.sut.purpleteam-labs.com, which is deployed using the PurpleTeam infrastructure as code system under test project. The new bugs panel of the CLI shows bugs over and above any specified alert thresholds. If this count is above 0, then you are going to have at least one failed test session. The total tester progress meter to the right of new bugs shows the combined progress of all testers. These logs I'm showing you are the raw CLI logs taken from the current finished test run. This particular log is from the low priv user test session of the current test run, currently being written to the top of the 2 CLI window panes as we speak. You'll notice that this particular test session is only testing a single route, the profile route of our system under test. This particular log is from the admin user test session of the current test run, currently being written to the bottom of the 2 CLI window panes as we speak. This test session is testing 2 of our system under test routes, the profile route followed by the memos route. As you can see, the server tester is currently inactive. Now we're looking at the tls-tester log. There's only ever one of these per test run. You'll notice the color codes in amongst the text. These are used to display the log text in color. We'll see how this works soon. We're looking at the same CLI logs as before. Tools such as cat, less and tail, if configured correctly, will render the color codes. Just reiterating that these CLI logs are currently being written. I've just taken them from the finished test run. This is the low priv user test session CLI log from the application tester. As you can see, this is a failed test session. This is the one and only TLS scanner test session CLI log that I showed you before, but with the color codes rendered. These CLI logs are what is printed to the CLI terminal if you are running it in CUI mode versus no UI mode. Right arrowing and left arrowing in the CLI terminal will switch between the different tester windows. As you can see, this is a failed test session. When you see the outcomes have been downloaded to message, that means the test run is complete and you can now inspect the report files generated by the emissaries and the result files generated by Cucumber. This is what the outcomes archive looks like once it's been packed by the orchestrator and sent to the CLI. You'll notice the report and result files. This is the HTML report file generated by the application emissary, Zap proxy, for the low priv user app scanner test session. It lists the alerts or defects, along with how they were found, how you can reproduce them, as well as directions for fixing them. This is the HTML report file generated by the application emissary for the admin user app scanner test session. This is the HTML report file generated by the TLS emissary, testssl.sh, for the one and only TLS scanner test session. This is the Markdown report file generated by the application emissary for the low priv user app scanner test session. This is the Markdown report file generated by the application emissary for the admin user app scanner test session. This is the CSV report file generated by the TLS emissary for the one and only TLS scanner test session. Here I'm highlighting the severity levels. These can be one of low, medium, high or critical. Refer to the job file documentation for further details on these. This is the JSON report file generated by the TLS emissary for the one and only TLS scanner test session. These are the three ND-JSON result files generated by Cucumber for the three test sessions: low-priv user app scanner test session, admin user app scanner test session, and the one and only TLS scanner test session. The app scanner admin user test session for the profile route has completed. It's now starting on the memos route. The app scanner low-priv user test session for the single profile route has finished. The log, which has just scrolled off the screen, provides defect counts and details of where to look in the reports. This is the log and outcomes files documentation. The app scanner admin user test session for the memos route has completed, which means the test session it's in is finished. In this case, both low-priv user and admin user test sessions have failed. The CLI log file that I showed earlier contains details of how to use the report files to locate and remediate the defects. You'll also notice that the stage 2 containers have been brought down. Now we've just right arrowed to the tls-tester to watch it finish. The test session for the TLS scanner has now finished. This also failed because the defect count exceeded the alert threshold that the build user defined in the job file. You may also notice that the total tester progress meter hasn't reached 100%. This is because the server scanner isn't currently enabled. As you can see, the outcomes files have been downloaded for you to inspect.
We look for contributors to come and join the OWASP PurpleTeam core team as well to help us continue to make PurpleTeam awesome. Thanks.